All right, so you guys have any questions from homework? And let me say this might spur some questions. We're going to have a quiz on Tuesday on chapter 1. So is everybody doing chapter 1? You should have, if you don't have a textbook, you should have copies of chapter 1 homework, so you should be able to get into it. Somebody tried to check the book out from the library or from the Math Study Center. They should be there. So if you need to do that, you can.
Yeah.
There you go. Cool. All right. Yeah. Success. So any questions from chapter 1? Is that going all right? All right. So we're going to get into chapter 2. And what I want to do today, I want to focus on solving all kinds of different equations. And then Tuesday after the quiz, we're going to focus on word problems. And there's a little flyer out in front of the door. I keep forgetting to remind myself when this is happening. There's a word problem workshop happening, I think, next week. I can't remember now. But the Math Study Center is going to put on workshops throughout the semester, and I'll try to let you know about it. You should be getting emails about them too. Are you getting any emails? All right, let me remind them to email people so you know. It's useful.
Could you please explain number 39, the question on 39 on chapter 1?
So 39, we did that one yesterday, but just this one here?
Yes.
So there were two ways I showed you to do this problem. Remember? So one way is just to start doing multiples of the bigger number. So LCD, of course, is the number that both of these can do what? What's the LCD mean? They both go into it. They can both multiply to become the same number. So 8 cannot become 12, so 12 is not the LCD. But what's the next multiple up? 12. Start counting by 12s.
24.
24. And does 8 go into 24? Yeah, so you're done. LCD is 24. Because now you can make that 24, you can make that 24. So then you make them like terms. Cool. Yes? Oh, now? All right. Oh, hold on to that question. Yeah, because I haven't even started lecturing on that yet. Yeah.
Number 147. 147.
47?
Yeah.
Oh yeah, that one's a freaky one. And you gotta love the unit of measurement. Do you guys know? You guys, of course, know about meters and centimeters and all that stuff. Especially if you do any, not construction, but you use tools at all. You got sockets that are 8 millimeters, 9 millimeters. That's almost the only place we really get to see that. And of course, what unit of measurement does America use? One that only 3 countries on the face of the earth use. This thing, do you know what our system of measurement is based on? The foot that we use, the foot?
Yeah.
What's it based on?
On the foot.
Yeah, it is. Actually, it is. It's a king of England. I think it was one of the Henrys. They measured his foot, and that's what the foot is. A freaking king of England is what we based our unit. And didn't we have a revolution? What the hell are we doing? We should go to metric. So our pints and gallons and teaspoons and shit, that's not very easy. I don't know how many teaspoons are in a gallon. Shit. Metric system's all about 10. And our number system is about 10. So metric system makes so much more sense. Do you know that we crashed a Mars, what was it, the Polar Explorer, I can't remember the name of it. We crashed a spaceship into Mars because 2 teams, one team was using metric and the other team was using feet and inches. So when they programmed the thing, they thought, we're about to smash. Oh shit, I think we did something wrong. Did you guys know that? Shit. So math, you know, if you use math correctly, you could save billions of dollars. It's crazy. So this one, which one? Oh yeah, this one is a little weird. 8 pints in a gallon. I can never remember that. So there's 8 pints in a gallon.
What number is
This is number 147. Yes, in chapter 1 homework. And they want you to figure out a formula that converts gallons to pints. So if they kind of give me the variables in the question, I can use G for gallons and P for pints. So then some of you guys might be like, the hell do they want from me? But they just want, all a formula is, like for example, in English, how would you tell somebody how to convert from feet to inches? How do you convert from feet to inches? Say again? Careful. If I have 3 feet, how many inches is that? Multiply by 12. You with me? So 3 feet would be 36 inches. So you just told me a rule about how to go from feet to inches. So to get to inches, you would take your feet and multiply by 12. 12 times the number of feet equals the number of inches. Are you guys with me? So that's what formulas do. They're just like shorthand for a rule as to how to get from one to another. That's one thing that formulas do. They do a lot more than that. So here I want the same thing. If 8 pints are in 1 gallon, if I had 2 gallons, how many pints do I have? 16. Is that cool? So if I have gallons, how do I get to pints? What do I do with the number of gallons? There. Done. So multiply by 8. 8 times the number of gallons equals the number of pints. Is that cool? You kind of with me a little bit? So, I mean, math, really, in one sense, in one application, math is a shorthand for a longer English statement. It's a very quick way to tell somebody, if you know G is the number of gallons, you multiply by 8 to get the number of pints. See how long it took me to say that? Here's how math says it. 8G equals P. And math goes, come on, I didn't got it all day. Right? So it's a very efficient way to say things. All right, how are we doing so far, you guys? All right, okay, cool. I think I'm at the point where I'm just happy you guys got out of bed and came. I haven't taught this early in a while. All right, cool, good. Beep. Beep. All right. So anything else from chapter 1? Homework? Yeah.
For 100, on page 85.
100?
Yeah.
Oh, write the fraction or mixed number as a decimal. Right? Whoa. Take stuff away here. So the 100 is 2 1/5. Before anybody says something, you might have gotten off track on numbering. I don't think I assigned this one, but it's okay. Don't freak out.
But, okay. Well, I mean, I was kind of confused on how it was like written or put together.
I'm not. Don't worry about it. Don't just try not to do this too often. But I'm going to do a lot of multiples of 3 and multiples of 5, right? So 3 through 153. So it's 3, 6, 9, 12. So every number, every problem you do should be divisible by 3. And don't you love it? Your math teacher makes your homework a math problem. But oh well, you guys will get over it. But it's okay if you get off track. You don't have to go back and redo it all. Just don't do it too often because then it makes it harder for me to grade. But you can ask me any question out of the book you want to. So if somebody asks me a question that's not in the homework, just sit there and take it. Right? You can ask me whatever. So here, this is a mixed number. How do I make this into a decimal? You could, but there's a little quicker way. I think you said make it into an improper fraction. You could, but there's a quicker way.
Multiply the coefficient by the bottom and then add the top.
So that's making this into an improper fraction, right? A top-heavy fraction.
Yeah.
But I don't need to do that. See, 2 is 2. 1/5 is the decimal part, right? So I don't need to take 2's done. 2, now how do I make 1/5 into a decimal?
5 divided by 1.
Or the other way around?
1 divided by 5.
Yeah, you could do 5 goes into 1. Has anybody got a quicker way to make that into a decimal?
0.2.
Yeah, why is it 0.2?
Because it's a fifth of 100.
Yeah, what? Okay, cool. So you can make that 100, 5 goes under 20, but then you got to move the decimal back. But what is 0.2 as a fraction? 0.2, what is that as a fraction? True, 2/10. And what's 1/5? So if you can make a fraction out of 10, it is a decimal. If you make it out of 100, it is a decimal, right? Because decimals are, and our numbers is based on 10. So 2 is already 2. 1/5 is 2/10, so 1/5 is 0.2. Done. Now the other way you could do this, is one way to do it. The other way, like you said, is do 5 times 2 plus 1. And then do 5 goes into 11, and you'll get 2.2. Right? But either one of those ways. But if it's a mixed number, it's called mixed because that's already a whole number, and that's the fractional decimal part. So you don't even have to worry about the whole number part. That's done. How are we doing? Is that decent? All right. Okay, cool. Yes, ma'am.
Can I just get a clear answer on like how the homework works then? Because I'm not sure I understand that. Like, what problems are we doing? Because it's
3 through 153, so it'll be every third one, right?
Every third.
So 3, 6, 9, 12, blah, blah, blah.
Okay, I just wanted to make sure because I don't think I understood it. So.
But if you're doing this, you can go 27 and then you do 31 and then you do 34. See, so you messed up a little bit right there. You don't have to go back and redo all the homework. Are you with me? Just try not to do that too often. Because then when I'm grading, I'm like, oh shit, man, I got used to all these other answers now. Oh crap, I got to grade. Does that make sense? But you don't have to redo the whole damn thing if that happens. The reason I do that is because, could you imagine if I try to pick, do you know how long this would be if I went in there and picked individual questions? That list would be freaking long as hell. So the every third one is just a quick way for me to give you a sampling of stuff. Cool. All right. I don't want the assignment of homework to be a problem, right? The homework is enough of a problem.
Question: what if you're given a fraction like 4 and 2/8? How can you change that?
Let me make sure. So 4 and
2/8.
Let's make it 4 and 3/8. Okay. So obviously, can you make this 8 become 10? No, right? Not easily. You with me? I love it. Some of you guys are like, what the hell? If it was 5, I can make it become 10 easy. It's freaking 8. I can't make that become 10 easy, right? So then, for this one, you would just, I would say the 4 is done. 4 is done. It's 4 point something. And then how do you make this into a decimal? Yeah, you just divide. Cool. And you obviously should be able to do that. I know a lot of you guys are probably going to do it in the calculator. Just to remind you guys, on a test, there will be a part 1 where you cannot use a calculator at all, and then a part 2 where you can use a calculator to check your work. Right? So just be sure you know how to do all this stuff by hand. Yeah.
Are there quizzes you can't use a calculator at all?
Yeah, normally quizzes I don't let you use calculator because I don't give you anything exceptionally freaky. Plus, it's just to help you get used to not using a calculator. Right? It kind of irks me a little bit when I say what's 7 times 6 and somebody reaches for the calculator. You should know what 7 times 6 is. Get away from your calculator. Stop. Right? If you don't know what 7 times 6 is, no, get on it. Figure out what is 7 times 6.
42.
Oh. 42. All right. So get on it. Do your multiplication table. Sit there and repeat them to yourselves. I don't know, high school nowadays using calculators a little too much, right? We need to know this stuff. I know calculators can do it, but we're the humans. We should be able to freaking do it. I don't want my calculator knowing more than me. Shit. Well, not always. All right. Anything else from chapter 1 before we get... All right, so let's get into chapter 2. Let me talk a little bit about it, and then we're going to go to this little workbook thingamajig and do some problems out of there. So part of what Math 88 is supposed to do for you is introduce solving equations. So wherever you guys came from in your last math course, you should have done a little bit of solving equations already. But let me just ask you this question. All right, this is not even necessarily math. Truly, if I've got a number and I take 7 away from it, I get 3. So what's the number? If I have a number and I take 7 away from that number, I get 3. What's the number?
10.
10. So what did you do to figure out the number? You added 7. You undid what I said I did. So if I had a number and I took 7 away and I got 3, you're like, well, if I add 7 back on, I get the original number back. Right? So the whole idea of solving equations is whatever's currently being done to x, I want to undo it so I can work my way back. Now, that was relatively simple, right? I said I take 7 away from a number, you get 3, you're like, well, it's 10. But what if I said I take 7 away from a number and then I add twice that number and then I subtract 3 times the sum of that number, and can you keep all that shit in your head? I can't either. So then that's where algebra comes in. It says, let me help you set up what the problem is, and then you just start to attack it. Right? So I can't do everything in my head. I need some help, and that's where algebra comes in. It says, let me help you out. So for example, let's just do a couple simple little problems here. So if I add x plus 8 equals negative 2. How would I solve that? Yes, sir?
You subtract 8 from the left side of the problem.
I love it.
Yeah.
Because what's your goal? What's the goal in any solving equation? What's my goal? Get x by itself, right? So very often you heard, get all your x's on one side, get all your numbers on the other side, that kind of thing. So no matter what, I mean, as you go through your math career, you're going to learn much more complicated operations than addition. But every time you have an equation that's got some funky-ass function in it, what are you going to do? You're going to do the opposite of that function. So if I have addition, I'm going to subtract. So then I'll get x equals
2.
Negative 10.
Yeah, negative 10. Cool. And what I've noticed also is I certainly cannot claim to be the neatest person as far as how I write. Or would you agree with me on that? But what gets in people's way a lot is you guys don't organize things well. The problem's already hard enough. And then if you're in there just putting shit all over the place and then going, well, there's a 7 there, there's an x there, I'm done. You got to keep things organized. So what do I mean? I get stuff like this. I get stuff like... I get stuff like this. Here we go. I get somebody will do something like this. At -2 minus 2, x is 5. All right, let me just let you guys, just don't write that down even. Don't write that down, because that's so horribly wrong. So this person knew they were supposed to get the numbers together. But algebra has a very kind of rigid setup, and it has to have a rigid setup so that everything stays in the right place. So if you're not conscious of things have to be in a certain place, then you feel like you've done work, and you have, but then everything's in the wrong. How did, this is definitely 5. But then if you write it, it would be x plus 5, and the equal sign is here, and what's on this side? 0. Yeah, so you're not done yet. But you guys understand what I'm trying to say? I mean, there's all different variations on this, where people just say there's x's, and then there's an equal sign, and I got an 8. Let me put an 8 there. No, it's got to kind of flow. So you have to be a little organized for yourself when you're doing this. All right, so what's the right way to do the problem, of course? Yeah, subtract 7, because your x's are on this side. I want my numbers on the other side. Bam. Now, real quick word, because we're going to get to equations that have no solution, or equations that have infinite number of solutions. Holy shit. So let's talk real quick about what the hell exactly does this mean? What does this mean? Yes, ma'am.
That if you plug in -5 to the original equation, it's going to
Kick ass. Right? And that, of course, is how we check it. This means that when this is true, when x is -5, then this is true. So to check it, you make x -5 and you see if it works. And that's how you check an equation, right? Good. So be careful in the homework. They might ask you to check your work. And if you don't check your work, I'm going to make you do it again. Right? So if they ask you to do it, you should do it. Cool. I like it. All right. So let's get some more interesting equations. Because I have a feeling that most of you guys are like, I know how to do this, Jeff. I think that's true. It's that intermission. What is that? Ding! Tea time. So obviously, what would I do here Kick ass, right? So whatever the operation is currently, I'm going to apply the opposite operation. I love it. So that, how does that change ever? Never. It never changes. It's all in mathematics. Whatever funky ass equation you've got, whatever the operation is, you do the opposite to kill it. So if I multiply both sides by -4, you get, bam, -48. Kick ass. But now watch this. This is where things get interesting. This is a mistake. I get this all the time. I get this all the time. And of course, what mistake did I make?
You added where you should have added.
Yeah, how can addition do a damn thing to this operation? This operation is multiplication. So addition can't touch that, right? So that's not good. So of course, what should I have done?
Divided.
Yeah, divide by what? -3. Bam. That poor 3 has been through some shit, right? Cool. So you could get fractions as answers. Don't think that means you made a mistake. It just means the answer is a fraction, right? The answer could be the funkiest number known to people. I mean, you never know. It could be anything. All right, maybe. Let me show you another mistake that I get all the time. By the way, I hope I'm not freaking out using old Roman numerals. Remember good old Roman numerals on the some clocks and shit? So 4, 5. I get this all the time. And again, this is a mistake. If I'm not careful about writing a mistake down, I always say to somebody, but you said this is how you do it. No, that's a mistake. I made a mistake. What mistake did I make?
You added 2 on both sides.
Yeah, exactly. Your brain said, well, 2 goes in 8, 4, and you got to go, well, that's nice, brain. Ain't got shit to do with this problem. Because the numbers never tell me what to do. What is it that tells me what to do is, why is my variable not alone? So, why is my variable not alone?
Because you're multiplying 8.
Yeah, there's an 8 with it. So how do I get rid of it? Divide. Because right now it's multiplying by 8. Divide by 8. Now that's the right answer. Okay. Kick ass. All right, cool. Okay, good. So let's start getting a little bit more interesting. Ooh, yeah. That looks gross. So, I mean, they can have a problem. The only reason this problem is more difficult is because it's got fractions in it. So take a second and try to figure that out. Solve that equation. All right, so how do I solve this?
You subtract 2x.
Cool. So x is already kind of like, all my x's are right there. In fact, it doesn't even have a coefficient, so if I can just get rid of this freaking 2/5, I'll be done. Right? So if I subtract 2/5, so now what do I have to do with this? Yeah, and this is an example of an easy, because what if 5 and 7 have in common? They have nothing in common. You see what I mean? Like 8 and 4 have 4 in common, but 5 and 7 are prime to each other. They don't have anything in common, so that's the one time that the LCD is the product. So 5 times 7, so this guy needs a 5, this guy needs a 7. So you get negative 20 35ths minus 14 35ths, so you get
30.
negative 34 35ths. Kick ass. So just because a problem has fractions in it does not mean it's automatically completely equal, right? That was one step, and then I just had to worry about LCD. And you cannot let LCD be an evil thing. Right? LCD does not stand for little crappy demon. It's lowest common denominator. It should not be that evil. Okay, so let's take the next step up. A whole nother level problem. What's that? Let's see. So what do I do when I have multiple things going on? Yes, sir.
Try to get the like term, combine your like terms to get those to one side. So if you take, you subtract 3x from that side to your 7x is 4x plus 3, or negative 5 equals 4x plus 3.
I love it. Cool. It's a good first step. So is there anything to do on either individual side? No. All my like terms are together already. It's nothing that's separate. So that would be the first thing I would look for. And actually the very first thing I look for in an equation is parentheses, because then I might have to distribute something, right? And then I can get my like terms together. But this, everything's already together on both sides. Now it's where you got to get x's on one side. And why is it a little bit better to subtract 3x, like you said, instead of subtracting 7x? So you don't get negatives. What screws us up? Negatives. What's the one thing that screws up the most? Negatives. So if I have an option to not let there be a negative, I will take that option. Right? Even me, I'm really good with math. And if I cannot let a fraction or a negative show up, I'm going to go that way. Because I'm a human. We make mistakes. So I'm going to subtract, get my x's together. Wow. And of course, now what do I want to do? Yeah, now I want my numbers to go the other way. So I took my x's this way. I'm going to take my numbers that way. And I always get, somebody does this, and then the next step is just 4. But of course, those don't cancel. You got to make sure what you're doing is actually killing that thing. So I get negative 8 equals 4x. These are gone. Bam. And then divide by 4. Kick ass. So negative 2 equals x. Or if you like, you can turn that around. X equals negative 2. Kick ass. All right, so let me be really evil and just give you the worst problem we've seen yet and make you do it yourself. I'm way up there in my Roman numerals. That is definitely disgusting. The worst one we've seen yet. Do what you can. I just want to see where we are, how we feel about things. So this equation actually is not any more difficult than any equation we've done so far. It's just got more in it. So it's just a little bit longer, right? But what's the very first thing I should do? Distribute. So then I can get all my stuff separate so I can move them around. So what am I distributing here? Now real quick, I'll have somebody say this on the next line. What did they do wrong? Well, what did they really do wrong? What rule did they violate?
They didn't negative there?
No?
No.
Do you see where that came from? Where did that 2 come from?
I know they did. They
They
subtracted.
Oh, shit. Yeah, they subtracted before multiplying, right?
Yeah.
So,
They should follow the steps.
yeah, they got to follow PEMDAS. So don't think that PEMDAS is like in the first section and then it's never there. PEMDAS is forever, right? It's like the underlying grammar of math. So if you do that wrong, you're speaking gibberish, right? So that's gibberish. So this, I got to distribute -2 through here, right? So what do I get there?
4 minus 6
plus
2x plus 5
plus 5
equals
equals 18
Good.
plus 12x.
Gas. Okay, cool. And now, what do I do? This side is done for the moment. He's just sitting there waiting. What can I do on this side?
You put the
4 minus 6,
plus
-2 plus 5, 3.
plus 2x.
and then
And see now, real quick, isn't this look just like the problem we had a minute ago? Very often, no matter how the problem starts, you'll get to a point where you have numbers and x's, and now you just pick a way to go with your x's, pick a way to go with your numbers. So what do you want to do with your x's?
I would subtract 2x.
Yeah, good, so I keep my x's positive, right? So subtract 2x. Bam. So now, see how I'm being, so 3 equals 18
Plus,
10
plus 10x. Kick x.
then subtract 18 on
then
both sides.
subtract 18
Good. Then subtract 18 because I took my x's one way, I take my numbers the other way. Subtract 18,
you get 15
negative 15,
into 10x
10x. Divide by 10.
then divide by 10.
and then divide by 10. So you almost always divide last. So divide by 10. And what's wrong if I just stop there? If I circle that, I'm going to take points off.
It's not in the lowest form.
Good. It's not reduced form. So if you reduce this,
Negative 1 half.
-3 over 2. Cool. I much prefer a fractional answer than a decimal answer because a decimal answer most often just came out of the calculator. I don't want the calculator doing work for you. Yes? Oh, okay, let's try it out real quick. I like that question. That should not change the answer, right? Because no matter which way you go, it's the same equation. So right there, if instead of doing what we did, we subtracted 12x, right? So I took this way. Bang. Is that cool? And the 2x minus 12x, negative 10x. And then what do I have to do with my numbers? I gotta subtract. 3. All right, so subtract 3, negative 10x, it's 15. And divide by negative 10 this time. But see how they both end up negative? Just this one had the 15 was negative, and that one has the 10 is negative. At the end, the answer is going to be negative, so math doesn't care which way you went. Either way you go, you end up at negative 3 halves. Yes, sir?
Do you want us to keep it like that, or do you want us to go like 1 and 1 half? Negative 1?
Oh, that's fine to keep it improper, unless the problem says your answer must be a mixed number or something, right? I keep those ideas separate. You don't have to make that as a mixed number, right? But normally, in the real world, I wouldn't say how long until you're done. And if you say, oh, about 3/2 hours, I look at you a little weird. Like, who the hell are you? You'd say 1.5 hours, right? So if you do make it into a mixed number, that's beautiful. There's nothing wrong with that, but you don't have to.
Okay.
Cool. All right. So let me just say a quick word. I know some of you guys right now are desperately bored, which is fine. Bored right now is good. It just means you know all this shit already. I'm trying to talk to people that haven't had math in a while. that forgot this stuff, because equation solving is the bread and butter. Word problems, the equation solving should be the easy step. Word problems, creating the equation is the hard step. So you really, you got to get the solving equations down. That's the bread and butter of math, right? Bread and butter. Okay. Last thing I want to talk about, and then I'm going to let you guys do some on your own, are weird-ass equations where the answer doesn't exist, right? Those freak us out. Has everybody got what they want here? More than you wanted? Okay. So, I mean, math is a way to describe real life. No matter what you think, that's a true statement. So, in real life, if I had a lemonade stand, you with me so far? And you know, if I charged more than $1.50 for lemonade, I'm probably not going to do very well. So I got my lemonade stand, and I'm like, let me set an equation up and figure out what do I need to do in order to make $18 billion in a week in my lemonade stand. You with me so far? All right, so you all know you're with me, but you're like, how the hell? So if I make an equation and I set it equal to 18 billion, math has to have a way to say, you're crazy, dude. You understand? Math has to have a way to say to me, that's impossible. So that's one place where this might come out of. There are equations that have no answer because there's no way to do that thing physically. Do you understand? So this is why sometimes math doesn't have an answer for an equation, because it was bogus in the first place. So can anyone tell me, why is this equation, why do you know this equation is already bogus? Don't try to solve it. Why is that equation as it's written bogus? What's it say? There's a number that when you add 2 to it, keep going, there's a number that when you add 2 to it, you get the same thing as if you added 5 to it. Is there a number that does that shit?
No, there's not accepted.
There's no number that, 3, if you add 2 to it, you get the same thing as if you add 5. No, you don't. It's going to be bigger if you add 5 to it, right? So that math will try to solve that, but it's not math's fault that there's no answer. It's a freaking bogus equation. Just like the equation, blah, blah, blah equals 18 billion. That's bogus. That is not going to happen, right? So what? Now try to solve it. Try to get your x's together. What happens? Subtract x, and this is where you guys, you're so altruistic, you're so like little lifesavers. You want to save x's life. Like, no, x, don't die. And so somehow one of the x's is still there on the next. That doesn't make any damn sense. If x wants to go away, let it die. Let the poor little dude die. He's been around forever. X minus x is nothing. Then people circle this. Like, that's the answer. And I'm like, holy shit. So if I owe you $5, I'm going to give you 2, and we're even because 5 is 2. No. So remember, what did I say earlier about when you solve an equation, what does this really mean? When this is true, then this is true. So when is this true? Never. So when is this true? Never. So what is the solution?
No solution.
Not undefined.
No solution.
No solution. You must always tell me what the answer is. So if there is no answer, you must just say that. No answer. And more formally, no solution. So get away from saying undefined. Undefined is specifically for an operation you're trying to, like 1 divided by 0, that's undefined. No solution is specifically for this situation. Equation has a solution. This one, no, it does not have a solution. You got to say that. Cool. How we doing? All right? I like it. So then what would this mean? Solve this. Take a minute and solve that. And then I'll finally shut up for a little while. So there's one freaky situation. There is no answer. All right, there is no answer. And then the other situation here, the equation doesn't tell you what to do. We're the human. We tell the equation what to do. So we know we want to get our x's together. So you've got to subtract 2x. It just so happens the other side has exactly that, so then you end up at 2 equals 2. Ground shaking. I have discovered that 2 is 2. Oh my God, write a paper. So again, interpreting it the way we just interpreted this one. When this is true, then this is true. When is this true? Always. So when is this true? Always. So all real numbers. So if the variable cancels, then it doesn't matter what x was. It doesn't matter what number I put here. If I add 5, it's not going to be the same as adding 2. That's why the variable went away. It doesn't matter what you pick. It's always false. No solution. Here, it doesn't matter what number you pick. This is actually like a definition. Isn't this the definition of distribution? This is true no matter what x is. So that's what the math says. Shit, you started with a weird-ass equation. Here's your weird-ass solution. You're like, oh shit, okay, that means all real numbers. Don't just circle 2 equals 2. You will lose points, right? That's not a big discovery to make. All right, how we doing? So, let me shut up for a while, finally. A quick time check.
8:11.
Okay, 8:12, all right. Can somebody turn off one of the lights there? The one that's in the front? I think it's the one on the right side. Yes. So if you have the blue book, this is page 2 in the blue book. If you don't have the blue book, there it is. So take a minute. For a lot of you guys, this should be relatively quick. What I really want to focus on now is if you have any trouble with any of this, call me over. You can work together if you want to. I need to find out who needs the real deep help with this stuff. If it's easy, just get it done and sit there and stare at the wall.